Assalamualaikum and a very good morning. My name is Noorzafarina Binti Mohd Salihuddin. I'm final year student of Science Biology at University Technology Mara Arau. Today, I will be present my final project titled A Review on the Application and Development of Effective Microorganisms in Water Pollution Control, Waste Management, and Agriculture Improvement in Malaysia, supervised by Dr. Khairunisa Binti Ahmad Kamil. To begin with the presentation, we will have a look at the table of contents. I will be covered four main contents, which are the introduction, application of EM technology in Malaysia, conclusion and future research, and the last one is cited references. So, the first content is introduction. Here, I will explain what is EM and how EM solves the problems. Tsuruhiga, a Japanese horticultural artist at the University of Ryukyu in Japan, pioneered the concept of effective microorganisms in the 1970s. He discovered that a mixture of roughly 80 different microbes can affect organic matter decomposition so that it returns to a process that promotes life. Lactic acid bacteria and yeast are the most frequent microorganisms, with a lower number of photosynthetic bacteria, actinomycetes, and other species. All of these are compatible with one another and can coexist in a liquid culture. EM species have a distinct function and can be employed to break down biological materials in a variety of situations. Some of characteristics of EM are not genetically altered creatures, not pathogenic, not hazardous, not chemically produced, and they are cost-effective. Despite its potential, the first implementations of EM focused on agriculture. This is because due to the widespread use of synthetic agrochemicals, but have resulted in environmental deterioration and sustainable systems. The EM was then utilized as inoculants to increase the microbial diversity of the soil environment. EM works by outnumbering other soil bacteria, so as a result, the majority of other microorganisms in the soil follow them, inhibiting the activity of the few negative or opportunistic microbes. EM has been offered as a solution to many of the world's issues, such as small ponds, lakes, and streams. EM also can be used to clean wastewater, decompose organic matter to carbon dioxide and methane, control water contamination, livestock, household use, and reduce odor. Now, we are moving to the next content, which is the application of EM technology in Malaysia. Here, there are three parts that I will be covering, which are in terms of water pollution, waste management, and agriculture improvement. So, what is the application of EM? The concept of EM is transformation of a degraded microorganism into a productive and beneficial microbial ecosystem. A mass EM1, which is extensively used in gardening, indoor plants, washing, and fish pools, is the most appropriate and widely used product in Malaysian rivers. Some of the balls contain bokashi, which is a fermented organic substance derived from rice bran, oil cake, fish food, and sawdust. For your information, bokashi is a traditional soil modification performed by Japanese farmers to increase soil microbial diversity and provide nutrients to crops. To activate the bacteria, we must dilute the solution with water and add a little amount of molasses by acting as a food supply. EM must be kept in cool place between 20 and 35 degrees Celsius and ready to use when the pH is 3.5 to 4.0, yellowish brown appearance after 7 to 10 days incubation. When EM was introduced into anaerobic treatment plants, the reduction in residual sludge generation lowered the unpleasant byproducts of this decomposition. These facts imply that EM might theoretically aid in wastewater treatment by increasing effluent quality and decreasing wastewater volume. EM also can help to boost environmentally favorable microbiology which leads to a healthy environment by preventing the formation of non-beneficial bacteria chemical processes. Then, I will explain about the first application of EM, which is in water pollution control. Water pollution is a major problem in this era, so we are going to look either EM is effective in reducing the water pollution or not. From the research papers that have been gathered in this table, it is shown that the application of EM has improved the water quality in the study sites. The DO concentration is found to be increased in the study because of the oxygen in the water bodies is higher than before. When the DO is increased, it is shown that it is safe for aquatic life. When BOD level decrease, indicate that less oxygen is being extracted from the water, implying that the water is typically purer and more favorable for aquatic life. Next, COD increase was likely due to the greater demand for oxygen. This implies that water with high COD level contains more oxidizable organic material. The presence of excessive levels of COD in water will disrupt the water ecosystem, degrade water quality, and reduce the ability of water to self-purify. pH became more acidic was most likely caused by an increase in cyanobacterial density and photosynthetic activities, which consume carbon dioxide and raise the hydroxide levels in the water. The cyanobacterial growth, however, could not be stopped by EM treatment. Instead, the EM concentrations caused the water's pH to drop and the release of nutrients. After that, we are going to discuss about EM application in waste management. Waste management is a major problem in Malaysia, particularly for household trash, which are mostly organic and contribute to the greenhouse gas emissions in the long run. From the table, we can conclude that EM is efficient in handling waste management. This is because EM can reduce an unpleasant smell. Aspergillus oryzae and Mucor humilis are two types of fermenting fungi that help to decompose organic matter and control odors. Moreover, EM also improves compost mineralization through increased microbial colonization and activity. Next, pH readings in compost samples with EM additions dropped and reached an ideal range. The low pH during composting with EM indicates a good quality compost. Then, from this part, it can conclude that when compared to the control, compost with EM had a longer time of thermophilic phase, which is 8 days. The increase in temperature is a good indicator of microbial activity in the compost pile, as higher temperatures indicate increased microbial activity. To kill the pathogen, the composting temperature must be above 55 degrees Celsius for 3 consecutive days. Then, moisture content should be kept between 40% and 60% during the composting process to facilitate the growth of composting microorganisms. Excess water in the compost medium caused oxygen diffusion, which lowered the metabolic activity of the organisms. The organic matter decomposition process was restricted and retarded when the compost medium was either dry or too damp. Furthermore, the CN ratio is a frequently used indicator to assess the degree of decomposition in the composting process, since it might indicate the compost maturity. A CN ratio of less than 20 is considered mature and can be utilized unrestrictedly. Moreover, compost with a lower phosphorus concentration implies properties of compost created from green waste. After that, the rise in total nitrogen could be attributed to the dry mass net loss of organic carbon as carbon dioxide during composting. The N values may arise also due to the nitrogen-fixing bacteria activity, which is frequent at the end of composting. Increased microbial activity on organic matter raised potassium, promoting a high rate of mineralization. The increased K content was produced by rice husks, which is one of the key ingredients of compost medium. Last but not least is about agricultural improvement. EM is proven is effective in agricultural improvement, where it is mentioned in the study by Lee et al. 2008 that explain the result, which is the micronutrient and micronutrient concentration of quail dung were increased compared with quail dung without EM therapy. Besides, it increased the physical properties of the soils like the amount of humidity and ash. Potassium is vital in plant growth as it increases root elongation, controls ion balance, improves protein synthesis, encourages enzyme reaction, improves photosynthesis and food development. Some of the roles of EM in crop are control of soil illnesses via competitive exclusion, shorten the time required for biofertilizer preparation, and promotes plant development and reduces insect and pest population. Moving to the conclusion and future research. For the conclusion, EM is simple and easy to use, safe, non-harmful, low cost, and economically feasible, which has increased its application. In Malaysia, EM technology is gaining popularity due to its ability to reduce nutritional quality in polluted water, restore water quality, restore waste management, and in agriculture production. The Malaysian government has acknowledged that environmental consciousness is the most important factor in establishing a framework for long-term development. Overall, the EM are found to be effective in control water pollution, treat waste, and agriculture and achieve the objectives of this study. For the future research, continuous monitoring of the water pollution level, suitable purification treatment, and community participation in water resource management can assist managers in making wise decisions for water resource sustainability and management. Residents in Malaysia can also practice applying EM technology to decompose their waste. Farmers also can use EM solution and replace all the chemical fertilizers. Studies that are available in Malaysia is extremely limited in comparison to the abroad. More research needed about application of EM in water pollution control in Malaysia. Hence, the application of EM in various areas should be encouraged and supported for a better environment. These are my cited references that are used as my references in my writing. That's all from me. I want to say thank you so much for your time for listening to my presentation.